else to do. All right, cool kids, here we go. For anybody who is gone right now, you better start being on time and in class. Come on, don't start slacking off now. Hopefully you guys are all safe and still making it to school, or if you're sick, you start feeling better and you're actually watching the notes online. If so, hang in there. Here we go. On the class calendar, we are supposed to be starting section 4.6, which we most definitely will do. I thought maybe we'd do just a couple more U-sub examples because we didn't get a lot done yesterday. However, for today, you should have had all of the antiderivatives of homework fully attempted. But I do want to go over, as I was working with a couple people last night, I want to go over a couple tricky things you should have seen, you might have gotten stuck on, then we're going to grade those evens tomorrow. So in a way, you have a half day of grace. Sorry, Aaron, it's hard to make sure you get here earlier, but they're cracking down. But homework number 30, have it ready for tomorrow. Hopefully you have it most of the way done. We can answer a couple questions. You can get it all the way fully attempted. We'll grade it first thing real quick tomorrow. And then, as you guys remember, we have a test coming next Thursday. All right, so here we go. Coming on back. Yesterday, we were ending here. My stylus is somewhere. What type of integral is this? Part 1. Definite. How do you know it's definite? Come on, guys, wake up. How do you know it's definite? There are bounds, right? From A to B. There's no other way of doing this integral unless you want to expand it to the 8th power. No, right? Unless you want to expand to the 8th power and then try to figure out how to factor that thing that you do find. Sorry, Sarah, it's a tardy this morning. They're cracking down. It's okay, kid. Just get here early. Unless we want to expand to the 8th hour, we need to, or 8th power, we need to use U-sub, which we did do. But what is the new thing that we added at the end of yesterday? Not just do that U-sub, not just do that U-sub, but do this U-sub, right? We have to do U-sub not only for the function of U on the inside, not only for replacing the dx with something in terms of du, but also with the bounds. And that is what this step, or these steps, are for. Replacing the bounds with u's. That's the only legal way of writing a definite integral with u's in there. F of u has to be there, du with whatever corresponding pieces in order to make everything legal, as we've seen before, and then we need u bounds. Now, after we found u bounds, question, kiddos, how did I go from this step to this step? I was going fast at the end of yesterday. What was I doing? I was plugging in. But before I was plugging in, maybe I do this a little bit fast for some of you guys still. Maybe we're not so good at antiderivatives. So let's double check things. Sorry, Corey, it's tardy. They're cracking down. But as we plug in, or we don't plug in until we actually take an antiderivative, right? So we need 1/9 u to the 9. And normally, if this was an indefinite, we would plug in who u is. But question, kiddos, why am I not pausing to take that step? Why am I just going ahead and, there we go, going straight to plugging in numbers without going back to in terms of x? Because what kind of bounds do I have? Yeah, I have u bounds, so I can go ahead and plug straight in, right? I have to go ahead and get this in. Sorry, kids, it's tardy today because I cracked it down on me. So I don't have to go back in terms of x's. I can steal the u's, and the u's I'm going to steal is plugging in that 7, plugging in that -3. And most of you would think, ew, gross, I'm not going to do that, so I'm going to stick it to the man and box it and be done. And you're mostly right. But why am I going to go ahead and go that last step that I did yesterday of 1/18, 7 to the 9th power plus 3 to the 9th power? How can I do that?
Because it's an odd power.
It's an odd power. What does that mean, Katrina, when I raise a negative to an odd power? It remains negative. So in a way, I can actually pull out this negative, right? And I can do minus a negative is a positive. Sorry, kids, sorry. So then, plug and chug, don't even worry about simplifying because ew, gross, whatever, just box it, you're done. So, power are we going to approach this problem? Remember yesterday, can I solve this with a basic rule? No. Can I do some math, like distribute this square root? Do some math and then maybe do some division in order to make it look easier and like a simple rule? No. That's the only option I then have. U sub, which the U is already given to you in this example. But couldn't you guys have picked out this U anyway? Isn't he in the innermost? All right. Let's go through the process of U sub and quickly review section 4.5. After you choose U, what do you need to do next? Du. And that means we need to find the derivative of U. Derivative of 2 is 0. Derivative of cosine is? Negative sine of x dx. What do we do with this du expression next? Solve for? Good, dx. We get du over negative sine of x. That's what we're going to go ahead and plug in. And we're also going to plug in that u expression. We end up with the integral of sine of x is chilling. Square root of u goes in the denominator. Du over negative sine of x. Plugging in for dx. What was the last thing we learned yesterday as far as what to do next? You solve for the bounds. What is different about the definite integrals? What is different about the definite integrals is when we go to do u sub, which we're doing right here, when we go to do u sub, we also have to do u sub with the bounds. So we take the old a and the old b, they are x values as indicated by dx. And we plug them into u to get the new bounds. So let's get rid of all that extra writing and let's go back to the problem that we're trying to work on. So we have our u sub almost perfect, but since we had bounds up here at the top that were x's, we are not allowed to. It is illegal notation and it is going to lose you points if you say, oh, whatever, I'm going to keep on plugging in x's. So if you're like, whatever, I'm going to get it in terms of u, and then I'm going to go back to in terms of x's, and then I'm going to plug in. That's great and all, but you made an illegal step in between. Since we're going into terms of u, we are not allowed to write x bounds. That is technically illegal. So we need to come off to the side and say, who is u of, let's find the top bound, which is going to be the bound that corresponds to 2 pi over 3 after plugging in. And then let's find the bottom bound. Let's plug in negative pi over 3. Who are we plugging it into? U. Which means, who is u? 2 plus cosine x, right? So 2 plus cosine of, unit circles coming back to haunt us. 2 pi over 3 is 120 degrees, second quadrant cosine. Just to help us for sake of time, that ends up being, I heard someone say it. Negative 1/2. You're close. It's in the second quadrant. Negative 1/2. So 2 is 4 halves minus 1/2 is 3 halves. And that is going to be specifically my top bound because that was the top bound plugged in. Then when we go back to find the other one, we're going to plug in negative pi over 3. What quadrant is that in, guys? Negative pi over 3? Fourth quadrant. It's a 60 degree in the fourth quadrant. You need to think about it. 2 pi over 3 was here, who has a point of negative 1/2 positive root 3 over 2. Cosine is the x. Negative pi over 3 is down here. He has a positive 1/2 and a negative root 3 over 2. And cosine is the x, right? So we're going to go ahead and plug in, just to remind you, that's why I did unit circle off to the side. We can just plug in 2 plus 1/2. 4 halves plus 1/2 is 5 halves. The lower bound is the one that corresponds to plugging in the lower bound. So then we come on back to our expression and we say, all right, fine. Even though it's going to look weird, we have to make sure we put it in the right order of plug in the top, that gets us the top bound, plug in the bottom, that gets us the bottom bound. Do we like the 3 pi over 2? No, not 3 pi over 2. Wasn't it just 3 halves? Do we like the 3 halves on top and 5 halves on bottom? Not particularly. If we want to make it nicer, what could we do? Flip them and put a negative. But just for sake of argument, couldn't we technically just leave it as it is? If we leave it as it is, the signs cancel. What do I do with like random extra things that are constants technically on the inside? Yeah, you can pull it out. So I end up with u to the negative 1/2 du, what we need to solve. Power rule, right guys?
Yeah.
Okay, so we're going to add 1, add 2 over 2. Do we get u to the 1/2 times 2? There's a negative chilling from 5 halves to 3 halves.
Yeah.
Once again, you could have technically, if you really wanted to, flip the bounds and change the sign, but I'm saying, no, whatever, it's going to work out either way. U to the 1/2 is the same thing as what? Can I make it what we're more used to? Square root of u, right? Then we go ahead and do f of b minus f of a. I'm going to keep that negative 2 factored out just for sake of simplicity. I have square root of 3 halves minus square root of 5 halves.
Starting from here, right?
Yep, I'm plugging straight into u. I don't have to go back to x's because I changed my bounds. Does that make sense?
Oh.
With u substitution, we're saying we don't have to go back to x's. We changed the bounds. They are u's, so we're just plugging in, plugging in. We're just plugging in. There's no need. Actually, it would be quite disastrous. Not literally, but you guys know what I mean. For the problem, if we went back to x's, because we're all set up, ready to go with u's. Could you simplify? Sure, why not? The 6 is the man for right now. Sound good? Dun, 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 dun. I think technically I've been boxing things in black. I don't know why, just to make it stick out. So there.
We don't have to have the negative 2 each square root.
You could, but what I saw keeping is kind of like a coefficient that I could factor out and then do my f of b minus f of a on the inside. The other way that it would have looked is if I had kept it in. Just to kind of prove the point. You could have done negative 2 square root of 3 over 2 minus negative 2, which would be plus 2 square root of 5 over 2. So if you had brought it in, it would have been able to factor out the next step. So that's kind of just saving myself a little bit of work. Any other questions? All right. Then let's go ahead and just to prove one more point, let's go back to this page where I was like, we cannot do this integral. And I was totally right, you can't. So here's what I'm going to do. Let me go ahead and actually get a white pen and let me change the example and hopefully I don't make it super hard. Sometimes it's kind of rough to make up your own example. Let me do this. That's something we could do. Well, you know what? Let's do this. Let's just take out 10. I'll keep it almost the same, but I'll make it possible. I'll keep it almost the same, but possible. Just to show you the difference between the U bounds and the non-U bounds. Yeah. We're going to do it 2 different ways, with an X bound and with a U bound. But let me go ahead and finish the example and let's make it like 3x plus 1. How about that? Cool. There we go. If you were not to go to U bounds, if you were to do X bounds, which is what some of you guys are doing, I need to show you how to keep it legal. Okay? I need to show you how to keep it legal. No matter what, to solve this integral, we have to use, it doesn't fit a normal rule, it doesn't fit We can't just like divide and split up the 3x and the 1. They're stuck together in the denominator. No matter what, we have to use u sub. Sorry, no way around it. U sub 3x plus 1. The only way to solve this integral is with u sub. So whether you do it the old-fashioned way or whether you do it the new u-bound way, still have to use u sub to solve. Now, after we find u's, just like with all the other u sub, we have to find du, and guys, shout it out, what's du? 3 dx. Let's get the dx. 3 dx. We use this expression to solve for dx, right? To be able to plug in. Okay. Ella.
Is du the antiderivative or the derivative?
Du is the expression that we use to find our u prime, which would be the derivative of u. Now, we're not solving this yet, kid. We're just setting up. Remember u sub? We find u first. We find du second. And just for a quick reminder, du equals u prime dx. So that stays. We find this by saying, hey, who is your derivative? What's the derivative of 3x plus 1? 3 plus 0, which is 3. Does that make sense?
Yeah.
Okay. We need to anti-derive, just not yet. My goodness, go away. Okay. For both of them, we need to get those u's in that integral, otherwise we're not going to be able to solve it. So the integral of your u's in the bottom, if you want to, you can make it 1 over u. Then go plugging in for dx, which would be du over 3. For both of them, we need to get u's inside the integral. For x bounds, we would say something like, for x between 1 to 3. For x within 1 to 3, we can say something to the effect of, there's the indefinite integral, and I'm trying to solve it for x within 1 to 3. Why am I saying x? Because what kinds of bounds are these if I have a dx? X bounds. Exactly. Over here I say, I don't want to write extra words, I'm just going to figure out who is u of 3 and who is u of 1. Where do I plug it in for u of? To u, of course. And what is u of 3, guys? 10. What's u of 1? 4. Remember, just plugging in to who u is. So I can go ahead and put in a 4 and put in a 10. Yeah.
Why can't you just put in the 3?
Here's why. These both mean the exact same thing. So question, why can't we still just write 1 and 3 and say, whatever, we know what it means? What does the notation say if I put them here based on what we see over here? If we try to put the 1 and the 3, who are we calling 1 and 3? We're calling them u's. But are they u's? No, they're x's. Hence why, to be legal, we are not allowed to put 1 and 3 in the bounds of the left. It's illegal. It's completely wrong. We can put 4 and 10 in, and that's totally fine, but we can't put 1 and 3 in. And we can say something like for x equals, or sorry, for x within. We can say that to remind ourselves that we can't put them in the bounds or else it's illegal. Now, to solve it, over here on the left, let's see, we pull out the 1/3. We have the integral of 1 over u du for x within 1 to 3. Over here, we would pull out the 1/3. We have the integral from 4 to 10 of 1 over u du. It's looking pretty similar. On the left, how do you, Ellen, now it's time. How do you anti-derive 1 over u? The integral and the du are saying, fine, that, anti-derivative, and we want to. So how? We need to use ln. ln is the only function that has a derivative of 1 over u. Don't need plus c. because we're going to do a definite integral. Over here, we could do the same thing, 1/3 ln of u, except I can actually put my 4 and my 10 because I'm keeping them doing the same thing, factoring out the 1/3 to make it easier on myself. I can do the same thing as we did before and just say, hey, yay, he's an indefinite, no, he's a definite integral. Let's just do fundamental theorem of calculus. Over here, I have to say, not legal yet. I have to actually go back in terms of who u is. Guys, double check me because it's beyond my vision. Is it 3x plus 1? Okay. Then I can put the 1 and the 3. Then I can put the 1 and the 3. So u bounds has this extra little step right here. X bounds, we have to be writing this extra guy, and then finally, after plugging in, then you're allowed to write your indefinite integral. But now at this point, let's see if these turn out to be the same thing. Hopefully yes, because over here, you got u's, plug them in, ln of 10 minus ln of 4. Absolute value of 10 is 10, absolute value of 4 is 4. Over here we get 1/3 ln of 3 times 3 plus 1 minus ln of 3 times 1 plus 1. And if you guys simplify that, doesn't that end up being ln of 10 minus ln of 4? Don't they end up being the same thing? Yeah, as long as you do it legally, it should work either way. Just on the left, one more time, we have to be careful of our notation. Oops, sorry, totally just switched pages on you. We have to be careful of our notation along the way to make it legal. And then we have to plug back in to x's. U's, we do this one little step, and then we say, yay, let's just solve. Now guys, technically this is pretty stinking good. But you know what? I'm going to go ahead and show you what the AP guys would probably have as the answer instead. Wait, what? Does anybody know how that just happened?
Sorry, log rules.
Log rules! Isn't one log minus another log the same thing as 10 divided by 4? That was an old sum and difference property of logarithms. Anyway, long story short, they should end up at the exact same place. But to be honest, there are some AP questions where the AP guys love to force you to use u-bounds. Number 1 and number 2. I think it just looks easier. Corey.
Are you able to put that in your calculator the original questions dx over something?
You can technically throw this into your calculator because if you, or I should say once you rewrite it, wait, this is a great question, kiddos. If you're trying, or if you're able to plug an integral into your calculator, and if it has u's, or t's, or x's, you can still use the x button in your calculator for it. Remember, the calculator just says whatever, it's a variable. You have already set it up for whatever variable is in there, u's, or t's, or x's. You just want the answer of that. So you could plug that into your calculator with x's, and it would get you the exact same answer. Integrals in your calculator, do we need to review that one? Sure. Math, I think the easiest way to do it, unless you're, using some sort of graph. The grapher, you have to have your window including the bounds, which can be kind of yucky. Gives a nice picture, but whatever. If you want to go to math, go down to FNINT. Math, and then function integrate. If you guys want to put in 4 to 10 of 1 over x dx, you can test it with me real fast, because this actually is a common question that people get stuck on. What if the variables are different? Is the calculator going to mess me up if I use x? And the answer is no, because you've set it up to whatever this variable is. Just solve it. I don't care. Your calculator doesn't know who the x is in your problem. It just knows this problem that you're trying to solve. So you can do your function integrate. You could do from 4 to 10. Of 1 over x, doesn't matter the variable, you can do 1 over a, 1 over b, 1 over, oh, I'm in the wrong mode. You do 1 over n, that doesn't help. Sorry, I'm in Calc BC mode. Function. Make sure you do your 1/3 times. Since I'm back there, let me go ahead and do that 1/3 real fast. Second insert. 1 divided by 3. You can use your fraction if you want. There we go. So in that x, make sure you end it with a dx. If you want to put in u and du using the alpha button, you can. You would end up with, and is that at all similar to what we think it is, which is ln of 5/2, and the answer is yes. Dun, 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 dun. Nice. All right, let's go back. Yeah. That's just for you checking your answer. If you ever see an integral on a calculator portion of a test, a quiz, an AP exam, you just plug and chug that thing to your calculator. Don't you dare waste time solving it. If it's a calculator portion, you can steal. You can use your calculator to do it for you. But only definite. Sadly, indefinite, you still gotta do by hand. Okay. This is the random review thing that you guys have actually already seen. A lot of you guys have actually already asked me about this. It was on the practice test. We talked about it in class just a little bit. I just had this in the notes right here, so I was like, let's go ahead and talk about it and write it down, because it does randomly come up from time to time. A real quick reminder. But first, I have people falling asleep all over the place. Go give high fives. Pats in the back. Let's fight depression this morning. And sleepiness. Oh, come on, give high fives.
Yeah.
No.
Brandon, encourage your group. Give high fives. Pats in the back. Alright, here we go. Even and odd. This doesn't necessarily belong in 4.5, but whatever, I had it in my notes, so we're just doing it real quick. Alright, here we go. Alright, let's focus on back end. What kind of symmetry do even functions have? I know which one. No. If it's x, it's not even a function, you silly goose. Yeah, think of x squared. It's the easiest one, right? Totally on accident. I'll take it. Y equals x squared. If I can like copy and paste, the next one's not gonna look near as nice. Copy. Ah. There you go. See something? Wait, oh no, but x squared isn't odd. That doesn't work. Who would be a good example for odd? Okay. He's not perfect. I know, right? He's perfect. Alright, I'm trying. Okay. So I have y equals x squared as an easy example. Y equals x cubed as an odd example. If you remember real quick from pre-cal or beginning of calculus, I'll even do it in green because it's review. This is y-axis symmetry. This is origin symmetry. Remember, no function displays x-axis symmetry. A circle would, but that's not a function. Okay. My question to you is, if we are looking from negative a to a, which means we're looking from some point on the left and some point equidistant but on the right. Same thing for the odd, some point on the left and some point equidistant but on the right. Question, how do the areas of what's on the left and what's on the right relate? As for an even, how do the areas relate? They look the same numerically, right? As far as, I didn't like how that got darker randomly. For the even, they're the same, but they're both what sign? Positive, right? Why? Because it's above. For x cubed, they're the same, but opposite, right? They're the same but opposite. So if we were trying to solve an even or an odd, and I think this shows up kind of randomly in homework somewhere, maybe that's why I talked about it. I could shorten or make my work a little easier and just go from 0 to A instead of negative A to A, because as we know, 0 is always easier to plug in. We could go from 0 to A and say, hey, I just want to take this guy, 0 to A, and let's just double him, because it's going to be the same on the other side. For an even function, I can take from 0 to A, and I can just double them, because what's on one side is on the other. For odd, I can just say the answer is 0. How come? They cancel each other. As long as you have 2 points equidistant from the origin. If something is odd or has origin symmetry, we could just say, hey, whatever, it equals 0. If something is even, we can say, cool, let's just go from 0 to A, make it easier to plug in, and then just double it. Alright, kiddos, this is the end of section 4.5. I do want to quickly do one example that I saw from last night that came up a couple times. Did anybody find the directions solve the differential equation last night? Ooh, alright. So homework help. Homework help real quick. Let me do a tricky example too. How about that? Does that sound good? I also saw something like the following. Alright. What if I was to give you the following? What if I was to give you the integral? Let's say this. Solve the differential equation. I can actually spell equation. And let's say I give you dy dx is equal to x e to the 2x squared plus 1. I will just stop there. Okay. What are they asking us to do? Solve the differential equation. By the time you get up to this in homework, you should kind of look at this guy and say, wait. Excuse you, you haven't been over there the entire homework. Where has dx been for every single integration problem? The other side. Well, wait, hold on. Didn't we learn that we can move dx whenever we want? Alright, so the first step in any of these differential equations is get the dx where he's supposed to be, which is on the other side. So multiply him to the other side. Now wait, now who's missing? Now that it's starting to look normal, dx is on the other side. The integral. Alright, what we do to one side, we have to do to the other. Oh, do you guys remember what the integral of 1 dy is? It's just plain old y. So what they're asking us to do is take this derivative and go back to the original. But to go back to the original, we're going to have to find the integral of this guy. Now, why did I give you this guy? Because there's one in homework that has an e that might confuse you. Kiddos, who's you? Because this is not a basic rule. Oh yeah, take the guy in the power of e, right? U is equal to 2x squared plus 1. What's du? How do I use this little du expression? Solve for dx. And then the name of the game is plug it in, and simplify. Plug it in, and simplify. So we end up with, over here, y is equal to Then we go plug it and chug it and say the x, I don't know who he is, whatever, e to the u times du over 4x. Why did I say plug it in, then simplify? Because I can cancel out these little guys that are in common, right? Let's go ahead and reduce and reduce. What do we do with this random little constant that's chilling? Pull it out. Wait, how do I pull it out? Good. He's a 1 over 4, so I pull out a 1, 4. How do I take the integral of e to the u du? That's messy. Oh, he's the easy guy. E to the u plus c. Wait. Why am I not plugging in numbers? Because it's an indefinite integral. So therefore, my goal is not to plug in numbers. My goal is to get it back in terms of x. What was the original expression? 2x squared plus 1 plus c. Dun, 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 dun. Now what if, hold on. What if they were to give you one more clue? What if they were to give you one more clue? What if in the original problem, not only did they give you a differential equation, that's what we call this themabob. What if they also gave you something like f, let's just do a point. The point 0, and 2 minus 1/4 e. We'll just do that. I know it's not very pretty, but whatever. What if they gave you that?
So then we have
So for y you get 2 minus 1/5 e over 2 for x equals
how we can solve
and then you solve for c.
C. Yeah.
Can you solve for c?
Yeah.
Hold on. So we make it 2 plus. I was trying to double check I made a good one. Make it 2 plus instead of 2 minus. Okay, so whenever we have this, it's called a. Why is it called a? We use it to find who's missing and who's missing.
C.
C. And whenever they give us a point, isn't this guy an x?
Yeah.
And isn't this guy a y? So we have to go ahead and plug him in. So we can come down here and say, okay, when x is equal to 0, y is equal to 2 plus 1/4 e. We can throw in the rest of our equation. So we have our 1/4 e to the 2 times 0 squared plus 1 plus c.
Lots and lots of work.
Is it?
Yeah.
Isn't this just 0?
Uh,
Isn't that just 1? 0 plus 1 is 1, so this is 1/4 e plus c. 2 plus 1/4 e. Now you know why I put the 1/4 e. So we can subtract the 1/4 e. We can subtract the 1/4 e. Who does c equal?
yeah.
But if they're asking us to solve, do you think they just want c? No. They want the y equals with the c. Plug it in, plug it in.
They're so needy.
They're so needy. They want the entire thing. Dun, 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 dun. Alright, that was homework help. It had a lot of weird things that might show up. Andre, that's what you can. Solve the differential equation. You start with a derivative. You move the dx to the other side. Put your integrals in. And then say, let's go, let's go, let's go. And you end with a final answer. But if they give you a clue, right? Then we can go ahead, find that c, plug it in, and be done. Alright, kiddos, let's start section 4.6. Ooh! We've already talked about natural logs. This will be a cinch.
Yeah.
No.
Won't be awful, but we do have some new rules. As you guys start writing, these new rules, one of them, I'm putting down twice just because it's that easy to forget. But the rest of them, I wonder why they're on the card with the LN rule. Because they all have LNs. Get this rubber card down. Then we'll talk about it. LN, because we already had him earlier. I think we already did LN earlier, didn't we? In the basic rules with the E to the and B to the. thought so. As our book says, they call this section a natural log section with integration. Oh, you can't see all the rules. Where are we at? Forever number 43? Is that right? 42 or 43? 43, okay. Thanks, guys. We're getting there. Little by
seven more cards, but we still have like a whole semester.
Oh yay, that just kind of sounds good.
So you
We only have a chapter and a half left after this. We'll call it 2 chapters.
Yeah, but practice is easier than learning. That's true. Then like I can get
Yeah, I was
it done.
scared for like tests. Like if I didn't pass chemistry, I was like wanting this is down.
I don't know,
One
once
shot
you
for my SAT, like I could take like 12 times. COVID was not nearly as stressed. That was a great. Even though my AP didn't help me out. So it was really good SAT, but second and I walked into the room, like all the time, like public school kids, so I instantly looked smarter than all of them. So my hubris got me through.
Wow, that was wow.
Yeah.
There are some really smart folks. There's some
What's that sheet on the SAT?
not as smart private school kids, and so we are all the same.
at me next time this week.
Kiddos, when does power rule for integration not work? Oh, come on, when does power rule
When
not
you
work?
have 1 over
X.
X.
1 over X.
Remember? When we have x to the negative 1, the power rule.
Wait, does it really not work on any of those? I've solved questions of those. Clearly wrong.
Wait, no, it would be interesting if this one says like it's after the light.
Because tangent of X is like secant X. What? Yeah. Apparently, negative ln of absolute value plus n. It's ridiculous. How do you do this? Ew. I don't want to do chain rule.
Remember the whole x to the 0 over 0 thing? That's not so good when we're doing power rule for integration, so the only other way to actually integrate 1 over x is to use ln. That was just a reminder. We've actually already covered ln. We've already done this guy. Why am I putting him again? Because I want him on the card where all the other ln's show up. This is the ln card. I'll show you why in a second. This is the ln card. So let's start with the basic one that we should already know. And then, we have some more. This is forever number 43. We're starting this today, ending it tomorrow, but here's what I want to show you. Can I do an example?
Mm-hmm.
I know. I'll do an example down here. How about that? Is that better? Example, I'll sneak them in at the bottom.
Oh.
What if I was to ask you to integrate sine over cosine? Oh, no big deal. Integral of tangent. That's not secant or tangent or cosecant or cotangent. How does it work? U sub. Question. Who's in the innermost, sine or cosine?
Yes.
I know, but who's underneath? Cosine. He would be the u sub. What would happen if we made u cosine? Who would du be? Negative sine. dx. How do we always use the du? Get dx alone. Then the name of the game is plug it in, right? So we get the integral, sine, whatever, he's chilling, cosine, oh, he's our u. dx, oh, he's du over negative sine. What happens? Sines go Who? -1 comes out. I get 1 over u du. Wait a minute. Who has a derivative of 1 over u, aka what is the antiderivative of 1 over u? ln of who? Of absolute value of u. And then I say, who is u? U is cosine?
You was smart.
U is time. U is important. Whoa. Whoa. Wait a minute! What did we just find? Woo. Why do you think, if we could just find him this way, why do you think I'm making him a forever rule?
Make it quicker.
What do you think people typically forget?
That.
They think, oh, that must be a basic rule. The integral of tangent is secant squared? No, that's the derivative,
That's what I assumed.
right?
And then
Who is the antiderivative of tangent? I don't know. No one has him as a derivative. Well, now we know. Negative ln of cosine does. Guess how we could find cotangents?
the same one.
Very similarly, except instead of doing sine over cosine, who is cotangent instead?
Cosine over
Yep, we did the integral of cosine over sine. Sine would be the u. How would we integrate this guy? 1 over sine. It would be a party. And maybe we'll do it tomorrow to see where that rule comes from. But long story short, what looks easier? Wait. What looks easier? Jumping here in your head or having to think through all that? Alright, we got some more numbers to memorize. Cool kids. Jumping up quick is not enough. We'll play around tomorrow with a few more L anything. Bye guys. See you later. Happy Tuesday, make wish.